Hello everybody. I'm doing this video now after I disassembled my ABS unit. As you can see here, this is my exercise ABS unit, and I did this because I need to further investigate why after working some time well, my unit gave some error messages and stopped working. So in order to have time to deal with this, I flipped my braking system on my R1200CL on classic system. I did a video about it, you can see it, and now I'm interested to solve this problem with the ABS. While opening, I saw that in the computer board from my unit, this is not my unit, this is from the other unit, I saw that the protective lux that was over the circuit and components here was somehow affected by the brake fluid, I could see, but even if I did not see some real brake fluid inside, that effect was very well tunable. So I suspect that it was somehow a shortcut circuit inside the unit, and that induced errors in working of the board. So I'll have enough time for this in the next month. I even consider of buying software and the hardware necessary to diagnose the system, to see exactly what is happening inside, but while controlling it. And while disassembling the unit, I observed also another important thing, that I managed to take out the solenoid. So the solenoid, it's in this part here. You can see this in position. This is the other one. So the only thing that keep it in place is this O-ring here that will seal the metallic part of the solenoid towards the frame. And because it's a very important sealing point, I'm going to replace this one and all the rings as I mentioned in my previous videos. While doing this, I had the opportunity to measure these rings, so in case you want to source it, it's the same sources that I found and are presenting on my other videos. The dimensions are though different, so take this one too. The cross section is 2.5 millimeters, the interior diameter is 18 millimeters, and the exterior diameter is 23 millimeters. So it's a metric EPDM O-ring. Okay, so after taking this out, I could see that inside there is a metal piece. Then when you take it out, it's in fact a piston. So this is a main command piston that works in the system. Also inside you can see here there is also a metallic ring, that's an aluminum ring, and be careful with it because behind it on sides there are two holes, and from each hole will come out some valves with spring that you have to take care not to lose them. Okay, so this is a small presentation of this step in disassembly, and now because of this I was able to see how really this unit works, and this is what I'm going to present you right now. Let's see now how the system works. I did find this diagram of the integral ABS system that I have, and it's very easy to see that it's designed symmetrically. The front circuit, the rear circuits are identical, and what is specific, because it's an integral system, this cross connection between the command circuits. So if, let's say, the hand lever is activated, it will induce an action to its own circuit here in the piston, command piston, but also through this line here will activate a small piston here, which is called the integral piston, which will push the main piston and activate this circuit too. The same applies for this circuit when commands the first one. So this is how it works as an integral system. Now to speak further about it, I will just refer to one circuit, and you have it here. So when normally functions, when you press the lever here, it will induce hydraulic pressure inside the first region, the command section of the unit, which is with blue color, will push the main piston here, which in turn will push another piston here at the power section. And this piston will just pop out from this capsule here. At the same time, the lever will activate a switch that will activate through the electronic board the motor, which will activate also the pump, the hydraulic pump in the power section. This will raise the pressure in this chamber. This chamber is with red. So the red is the power section of the unit, the blue is the command circuit. The two fluids, they do not mix, so they do not communicate directly one to each other. When the pressure will rise here in the power section, it will come to a point when this pressure will push back this piston here and will come to a balanced position between the two forces, the one from the command, the one from the high pressure here. And that is a value of the pressure that will induce the braking power here. So as much pressure that we make in the command center, as much pressure that will induce in this one, but multiplied with the rate between the surfaces of the command and the power section here. So this will make the multiplication of power in the braking functioning. Now, what happens next? Let's say then we want to put a much higher force here at the command. So this will increase the pressure here and will have the tendency of locking the wheel. When this comes to effect, the sensor here will command the electronic part, which in turn will activate the solenoid here, which is with red. I don't know if you see it very well. Okay, so this one. This will induce a retraction of the main piston. So it will pull back the piston and lower the pressure from the high power section, as we should have lowered the pressure here. But this is just a countermeasure which the unit takes to lower the pressure transferred to the wheel. And of course, the new position of balance between the pressures here will induce a lower force, and the force sent to the caliper will be also lower. So this is how it works. I'll show it how it looks here. So the piston here is pushed by the hydraulic pressure when we apply the command. The piston will go here, and see, the piston in the high pressure in the wheel section will come out, and this will come to the balance between the forces and will establish a specific position where it will induce a specific force of braking to transfer to the wheel. Now, when the ABS is functioning, this solenoid will be activated and this piston will be pulled back, and this will reduce the pressure generated in the power section. A small mention is about what is inside here, and as you saw on the diagram here, this piston ends with a ball here, which rests on a closing and isolate the chamber of high pressure from the reservoir. So when the principal piston is activated, it closes this passing, so the pressure remains in this chamber and is transferred to the caliper. When the ABS is working, so this piston is pulled back, this passage is opened and the brake fluid will pass back from the high pressure chamber to the reservoir. This is how the pressure in this chamber is lowered. And also this ball here will close and open the passage when the forces applied to this mechanical complex will come to a balance. I told you how. So this is how this flow of the brake fluid here works. And by the way, I can show you now what happens when this system fails to work. I mean, the electronic command of the system fails to work, and as you know, it switch to residual braking mode. As you can see here, what means residual braking? Nothing electric works. So we do not have power to the solenoids, we do not have power to the motors and the pump, hydraulic pump in the power section. What we have is a hydraulic power from the hand lever or the foot pedal, which will be applied to this piston, which will be pushed further in. When this is pushed by mechanical means, it also pushes this piston here on the top. So, as this piston enters the high pressure chamber here, it will rise the pressure here. The ball inside is sealing that passage as I showed you. So it will be not too large but existent raising pressure in this chamber. This pressure will be transferred to the caliper, and that's the residual braking. So this is how we have it, and this depends on the surface here, but this surface, maybe you remember, at my unit it's not equal. For the front it's a little larger, for the rear it's smaller. From the other unit both are equal. So depending on this surface is the pressure that will be induced in the high pressure section and transferred to the caliper. This unit will have a better braking power transferred to the front wheels, but those are two calipers, and smaller to the rear. Well, the design of this kind of braking assistance, only mechanical, is not so good, as many of us know. So this is why BMW also passed the system to a better one, which is this one. So starting about 2005-2006, they changed the design of the ABS3 to this design, which comes from the automotive. What is better in this system is that there is no isolation between the command and the power section. They communicate directly. So from hand lever there is a circuit that goes directly to the caliper, and from rear also directly to the caliper. So even if this unit doesn't work at all, there is a direct connection, like a classic system, from the main pump to the caliper. What does this system better? When the ABS works, and I mean it senses that the rear tries to lock, this will be transferred to the electronic unit, which will close the valve here and will close the passage. So no matter how much we press the lever, there is no transfer of power, braking power, to the caliper. Even if the wheel is locking further, the system can apply even a forced returning of the fluid on this circuit here, using the pump of this system, and this will lower very quickly the pressure in the caliper, so will not let the wheel block. It's a very nice design, and maybe you ask yourself, why wasn't this used before, the one that we have? Well, that is because this kind of system that comes from automotive had a problem. So the automotive system, when the ABS works, will induce a kickback motion from the caliper back to the main pump for cars that is not annoying. It's acceptable. But for motorcycles, that is not acceptable. So after the design of the unit was much more refined and this kickback motion was eliminated, only then this kind of design could be used. And now it's in use. Since 2006, all the units, ABS units from BMW follow this design, which is a fail-proof. As I told you, it lets the fluid directly going to the caliper even if this unit doesn't work. One more information about this ABS system. Something that is a very big danger inside of it. Some people reported that occasionally you could end up in locking the wheel, and many of us consider that this could be just due to not properly maintaining the system, that is not changing the brake fluid, and the brake fluid could be infected with water or air, and that could lead to a boiling situation when the caliper hits while functioning. So the pressure in the power circuit could rise if the heat will inflate the air in the system, or it will induce the boiling of the water. So this is a possibility, but also I could find documented that there is another big danger with this system, and that is because when you apply the pressure suddenly on the command circuit, this will induce, of course, a sudden raise of pressure in the power circuit because of the pump inducing this high pressure here. And as you could see from my videos, there is a sensor in this high pressure area, and there is another sensor here in the command circuit area. So the ABS unit, the electronic brain of it, will monitor the sensors, the pressure sensor from both sections, and usually take the appropriate action. But if, as I told you, there is a very sudden raise in the pressure on the command circuit that will induce a very sudden raise in pressure on the power circuit, this could be just over the values that the pressure sensors could measure it, and will not take that in consideration, or worse, it can become defective at the same moment. So in that moment there is no information about the pressure, and then the electronic brain will not know that the pressure inside this circuit is too high. So it will just cease the function. It will see that is a malfunction is measuring the pressure, and will cease to function. What will induce that? Well, that will induce that the motor will continue to work at the highest rev, so it will create the highest pressure in this chamber here, but this time there is no countermeasure in this solenoid, so the solenoid will not be activated to decrease the power. So in this situation it will end in having a very high pressure in the power section even if the command ceases. So even if we take the hand off the lever, the same condition will apply. The high pressure will continue to stay here and lock the wheel. So this is a very unpleasant situation, theoretically possible, and also documented by some person who encountered it. So this is a very big danger for this unit, and I'm very seriously thinking about changing this kind of unit with the one from the next generation, which is much more safer. Well, unless you do not consider of a very hard braking, this unit is also safe, but who knows? Well, I hope you enjoyed my presentation. I hope you understood a little more about this ABS system as I became more and more aware of how it works, in order to repair mine, of course. So if you enjoyed, just put 2 thumbs up, yes, and thank you for watching.